board to the radio, and similar things. But have you any questions? Or come on, somebody, be neighborly.
Well, if there are no questions this time, I will be taking the opportunity to ask the first. You shortly addressed the AVRs, the difference between Van Neumann and Harvard. Can you elaborate a little bit more how you how you exploit these AVR because of these different architectures?
So you can exploit AVRs by attacks against the voltage and their debugging framework. Traditionally, voltage glitching has only been used to attack software within a chip. As you're running an application and the software is, say, fetching a byte from memory, you can glitch at that moment to make it fetch the wrong word. You can use this to bypass the access controls. But you can also do the same thing in hardware, because where there is a hardware debugging mechanism, it is also a digital machine that operates on a clock. Even better than this, you control the clock externally. So in the case of the AVR or the MSP430 or any other chip with hardware debugging, you can connect with a debugger and send it the command to give you access. It then looks at its memory and sees that you're not allowed to have access. So the state machine runs from 3 states. It begins in like a wake-up state where it fetches this value from memory. Then it proceeds into a fuse check state where it looks at this value and decides whether or not you're allowed entry. And then it goes to a 3rd state, which locks you out. So you have 2 state transitions. You have one from the initial to the check, and another from the check to the deny state. On each one of these, if you can mess with the value that gets latched in, you can fall into a random state. And in the case of JTAG, you've got a map that they actually give you as part of the standard. And if you look at this map and you pick any random location, you might land in the state where you are loading a word into the instruction register. You can always navigate from there back to the beginning by sending the right sequence of bits on the right input pins. So all you do is jump ahead of the fuse check and then navigate your way backward to the beginning where your debugger will work.
Thank you.
Yes?
Thank you. I will try that.
All right. Well, thank you and have a nice day.